A package delivery service successfully delivers a package on time 70% of the time. Which simulation could we use to model whether at least 3 out of the next 4 packages are delivered on time? See if you can figure that out. Okay, so let's see this first one. Drawing a card from a deck of 10 cards, 7 labeled on time and 3 labeled late, with replacement 2 times. Okay, so a deck of cards where you have 10 total, 7 on time, 3 labeled late. It is true, when you take one card of that, that will be a 70% chance that you're going to get on time, and then a 30% chance that you're going to get late. So that part looks good. You definitely want to do it with replacement, because if you took cards out every time you did it, it would actually change these. So I like that as well. But here they say only doing it 2 times. We would want to do this 4 times to simulate out of that 4 how many actually got on time. So I don't like that because they're only doing it 2 times. Drawing a tile from a bag of 7 tiles, 7 labeled on time, 3 labeled late. So that has the same property, which I like, 70% on time, 30% late. With replacement, I like that too, because it won't change this ratio as we pick things. 4 times. Yep, that's what I said. You want to do it 4 times to simulate each of the 4 next deliveries, or the 4 deliveries. Spinning a spinner with 10 equal sections, 5 labeled on time and 5 labeled late 4 times. Well, they're doing it 4 times, but the percentages aren't right. This would be 5 out of 10 would be on time, 5 out of 10 would be late. This would be 50-50. You want this 70-30. So I definitely like choice B.